There was a time when humans lived on Earth but didn't understand so much about our home planet. When we didn't realize how big it is, what shape it is, or how it's suspended in the solar system, in space, orbiting one of perhaps trillions of stars in the cosmos. That time is over, though, and the race for knowledge is truly heating up as we get a grip on the finer details of our existence as well as the wider and more fundamental facts. So, this is Unveiled, and today we're exploring the reasons why NASA is studying meteor smoke in Earth's atmosphere. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. On December 13, 2021, a NASA release led with the somewhat inconspicuous title, "Tiny Meteors Leave Smoke in the Atmosphere." Seeing as this latest article came just a couple of weeks after the launch of the agency's Double Asteroid Redirection Test, or DART mission, it would appear as though the study of space rocks had soared right back to the top of the agenda, if indeed it ever wasn't at the top of the agenda at all. Our leading scientists on Earth are then seeking more and more knowledge on asteroids and meteors. But to what end? The meteor smoke story was really published to coincide with the annual Geminids meteor shower. As NASA explains, the Geminids are actually a spray of pea-sized rocks that constitute the debris trail of a much larger asteroid, 3200 Python. Discovered in 1983 and measuring some 3.6 miles across, 3200 Python has the distinction of carving an orbit that takes it closer to the Sun than any other officially named asteroid in the solar system. But what affects us the most is what falls off the asteroid, a small scattering of tiny bits of rock that Earth routinely passes through, and so forms one of the brightest shooting star displays we get to see, the Geminids meteor shower. It's an often spectacular astronomical event, but it also serves to highlight what's really happening in space. When we look up at the stars, there can be a tendency to think that there's truly nothing between us and the twinkling lights above. But really, there's so much that's going on. Massive, jagged rocks circle through the solar system unseen, yes, but they and we also move through a vast blanket of dust and smoke. And that dust and smoke invariably deposits in the upper layers of Earth's atmosphere, and further down as well in the middle layer known as the mesosphere. NASA highlights past difficulties in analyzing atmospheric meteor smoke, explaining that the particles that make it up are just 1,000th the width of a human hair. This smoke floats miles above our heads then, and is truly tiny from a particle point of view. It isn't particularly accessible or observable, and has therefore proven exceptionally tricky for us to understand. The SOFIE experiment, conducted by a near-Earth satellite launched in 2007, remains one of our best attempts to determine what's really going on. The detection of meteor smoke isn't its primary purpose, but it's still managed to paint us a better picture of it while surveying the rest of the sky. Thanks to data from SOFIE, which stands for Solar Occultation for Ice Experiment, NASA concludes that meteor smoke is mostly made of 4 elements: iron, silicon, oxygen, and magnesium. And also that up to 25 tons of extraterrestrial material, including meteor smoke, makes its way into Earth's atmosphere every day. It's clear then that there's a potential for these particles from space to impact life on this planet in a significant way. And that's really the primary reason why NASA is intent on studying it further. So far, there are at least 3 examples identified by NASA as to how specifically meteor smoke might be making a difference. The first has to do with water formation in the mesosphere. Scientists suspect that it happens, but they're not completely sure how, because the hydrogen and oxygen required for H2O should need a hard surface upon which to react. The idea is that meteor smoke could be a contender to provide that hard surface, acting like a thin net of sorts along which the water develops. There's a similar suggestion regarding a more specialist atmospheric structure too, polar mesospheric clouds. Otherwise known as noctilucent clouds, polar mesospheric clouds, or PMCs, are rare, but are usually seen across polar regions at the height of summer. They have a distinct shimmering glassy appearance because they're made of ice. But for years, scientists again were unsure how that ice will have formed. It should once more require a hard surface, what NASA refers to as a nucleus on which to crystallize. In more recent times, however, the suggestion that meteor smoke could provide that nucleus has gained traction. Finally, though, could it be that meteor smoke directly impacts conditions on the ground as well? According to one theory, it might do. NASA has tentatively tied meteor smoke to what's known as iron fertilization, a key process in photosynthesis. Iron is an important part of the photosynthesis cycle, but we know that it's not generally as abundant on the ocean compared to inland. Nevertheless, photoplankton in the ocean needs iron so that it can contribute to photosynthesis. And now there's a suggestion that while much of it is blown across the sea from the land, some of that iron may be descending to Earth from the mesosphere. And what could be supplying all that iron from above? You guessed it, meteor smoke. This then implies something quite incredible and maybe a little disconcerting. If meteor smoke really is fueling photosynthesis in the ocean, which in turn is fueling life on Earth, then perhaps we're only here because of the dusty residue that's left over from passing rocks that generally burns up miles above our heads. And it could be argued that Earth only functions as it does because of all of the apparent random stuff that happens in nearby space. Suddenly, the meteor showers that we read about every year, or if we're lucky enough we get to witness firsthand, are much more than just a passing light show. They're a key contributor to our ecosystem and planet. So what can we do with this insight? How can we apply the findings of NASA via studies like the SOFIE experiment to our general way of thinking? Well, as much as we're increasingly aware that everything in the natural world on Earth is linked, perhaps we should be starting to view the solar system, the galaxy, and the universe in the same way. Because in just this one case, the one mentioned at the top of this video, if Earth didn't have the orbit that it does, and the 3200 Python asteroid didn't have the orbit that it does, then Earth would never pass through its debris trail, the Geminids meteor shower would never happen, there'd be less meteor smoke in the atmosphere, and ultimately a lower chance of photosynthesis in the ocean. And that's bad news for everything. It's been said countless times that the solar system survives because of balance, but this idea is typically applied to more general, broader conditions. For example, the distances of planets from the Sun, or the precise positioning of the asteroid belt between Mars and Jupiter. With the presence of meteor smoke, however, we're diving into greater detail than ever before. We're realizing how even the smallest objects in the solar system can have a major effect on how Earth works. And we're coming to terms with the fact that today, all of us are potentially reliant on a steady supply of cosmic dust and smoke. How does that make you feel? On the one hand, Earth's atmosphere has mostly worked in our favor for thousands of years, so perhaps there's nothing to worry about. On the other, we can suddenly see the fragility of all things, and so it's easy to panic. For now, let's just take a moment to consider how far science has come so that we can even consider these issues in the first place. On the timeline of human history, it was but a short time ago when we had almost no knowledge of the atmosphere at all. And now we're dissecting it with the finest of fine-tooth combs. To NASA and the rest, we do doff our caps. And that's why we're studying meteor smoke in Earth's atmosphere. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.